Okay, we're going to review some problems from your homework, section 4.5. We'll start with this fairly simple exponential equation, 3 plus e to the 4x equals 31. Now, the way you solve exponential equations is to get that exponential term all by itself on one side of the equation, and pretty easy to do that in this case. Subtract 3 from both sides. So e to the 4x equals 28. Now take logs of both sides, and what you want to do is match the exponential base if you can. In this case we can. We can take the base e log, which is ln of e to the 4x equals ln of 28. Now, we do this because then we can move that exponent out in front. So we get 4x times ln of e equals ln of 28. But remember from the log properties, ln of e turns into 1. So we just have 4x equals ln of 28, or natural log of 28. We just divide both sides by 4, and we get x equals ln of 28 divided by 4. Now, if we want a decimal answer, we put that into a calculator, and you get x equals, to 3 places, 0.833. And let's see, let's put that where we can see it. X equals 0.833. And if you plug that back into the equation, multiply it by 4, put it as an exponent on e, it will make the equation true. Okay, in this next example of an exponential equation, this is like number 4 of the homework, we have 1 over 2 minus 10 to the 3x equals 40. So your first task here is to solve for that 10 to the 3x. Get it all alone on one side of the equation, which means your first step is going to be to multiply both sides by that denominator, 2 minus 10 to the 3x. So why don't you do that? Pause the tape and get that 10 to the 3x on one side of equals. Okay, so when you do this, multiply both sides by that denominator. Then I would divide both sides by 40. Then subtract 2 from both sides. And that gives you negative 1.975 equals the negative of 10 to the 3x. Well, I want just plain old 10 to the 3x. So to turn that negative to positive, multiply both sides by a negative 1. And so you get 1.975 equals 10 to the 3x. Okay, now at this point, and this is what you should get, you can solve by taking logs of both sides. In this case, I would use the base 10 log because it's a base 10 exponential. So base 10 log, which is just log with no base, log of 1.975 equals log of 10 to the 3x. And now remember, the exponent rule allows you to move that 3x out in front. Now when we do that, we get log of 1.975 equals 3x times the base 10 log of 10. That was one of your properties. Base a log of a equals 1. So what you get is log of 1.975 equals 3x. Well, to solve for x, just divide both sides by 3. So log of 1.975 over 3 equals x. Now that is the exact answer. But you can plug that into a calculator. It's a base 10 log. Take that log and then divide in 3, and you get 0.098 5 if we round it off to 3 significant digits. If we round it off to just 0.099, it's a little bit too inaccurate. But I mean, I would count it correct if I said round to the thousands. But really a better way to round is the number of significant digits. So that's solving exponential equations. Isolate the exponential, then log both sides. Match the log base if you can. Okay, the next problem is number 8 from the WebAssign. Solve 6 to the 5x equals 5 to the x plus 4, which you look at this and you're kind of wondering, well, how do I isolate the exponential? There's 2 of them. Well, we do have one exponential on one side and one on the other. When we log both sides, those exponents are going to go out front and they'll no longer be a trouble to us. So that's what you do here, is you log both sides, where you can use either base 10 or base e, ln. I'm going to use ln because that's what they use in WebAssign. Either one gives you the correct answer. So we take natural log of the left side, natural log of the right side, and now those exponents can come out front. So we get 5x times ln of 6 equals x plus 4 quantity times ln of 5. And it's important you remember those parentheses around the x plus 4. Because our next step is to solve for x by distributing and grouping x terms and solving from there. Actually, all this is an algebraic linear equation. You have 5 times x times some number, ln of 6, equals x plus 4 times some number, ln of 5. You could do this in decimal form and get an approximate answer just by replacing those logs with the decimals. But we're going to solve it and get the exact answer because that's what they want in WebAssign. And the first step here is on the left, I'm going to just rearrange these factors. I'm going to put the 5 times ln of 6 times x. That's the coefficient on x. On the right side, I'm going to distribute x times ln of 5, which I've written ln of 5 times x plus 4 times ln of 5. Now it's a matter of grouping the x terms. This is sort of like the problems in section 1.2 where you group the terms with your variable and factor the variable out. That's what we do here. We subtract that 5 or ln of 5 times x term from both sides. So we get 5 ln of 6 times x minus ln of 5 times x equals 4 ln of 5. Now you can factor that x out. X times 5 ln of 6 minus ln of 5 equals 4 ln of 5. Now you just divide by that quantity, 5 ln of 6 minus ln of 5 on both sides, and you have your answer. So x equals 4 ln of 5 over 5 ln of 6 minus ln of 5. And that's the answer they have in WebAssign. The only difference is they put parentheses around those quantities. I didn't use the parentheses because we already had enough parentheses. I didn't want extra ones. But otherwise, this is how the answer is reported in WebAssign. Okay, we're going to move on to the log equations. And I'm going to do one like number 2 of the homework. Base 2 log of the quantity x minus 1 equals 4. Solve for x. And this looks a bit intimidating. Base 2 logs. Never solve the log equation. Well, it turns out it's a very, very simple equation. All you have to do when you have an equation like this, where you have log of some function of x equals a number, is rewrite it in exponential form, which is 2 to the 4th equals x minus 1. Or 16 equals x minus 1. X is 17. It's that simple. So these can be actually very simple problems. Okay, here's another one with just a little bit of a twist to it. We have base 4 log of x plus base 4 log of x minus 1 equals 2. Well, here we don't have one log equaling a number. Here we have two logs, but remember our log properties from the previous section. We can combine those two logs into one log. That product rule for log says log of u plus log of v is log of u times v. So these two combine into base 4 log of x times x minus 1. Now you can rewrite that in exponential form and solve it. So why don't you do that? Take it from here and solve it just like the previous problem. And get both the radical form of the solution and a decimal form out to 3 decimal places. Okay, so we rewrite the exponential form 4 to the 2 power equals the x times x minus 1, which is 16 equals x squared minus x when we distribute, or the quadratic equation 0 equal x squared minus x minus 16. And now we can just plug that into the quadratic formula, and we get 1, x equal 1 plus or minus the square root of 65 over 2. Well, if we use the negative, the answer with the negative sign, we'll get a negative answer for x, and we can't get a solution when x is negative. The base 4 log of a negative number does not exist. So we're only going to use the positive answer here. X equal 1 plus the square root of 65 all over 2. And if you evaluate that out to 3 decimal places, you get 4.531. Okay, and then the next type of log equation I'm going to look at is where you have logs, a log equal a log of the same base. And here's a simple example. ln of x equals ln of 2x minus 2. Now, because of the way the properties of logs, they're one-to-one functions, that means we can reverse the operation and just unlog both sides, which is the equivalent of the book calls it exponentiating both sides. But we can just drop those logs, unlog both sides, and we get x equals 2x minus 2. And now we just solve that. Subtract an x, 0 equal x minus 2, add 2 to both sides, x equal 2. Check it out, does it work? Does ln of 2 equal ln of 4 minus 2? And the answer is yes. Okay, we're going to do another problem. This is sort of like number 5 of the homework. Just a little twist on that. Here we have a log minus a log equals a log. Well, what we just did worked when we had a log equal a log, and here we have 2 logs subtracted equal a log. Well, what we just did on the previous problem isn't going to work unless we combine these 2 logs on the left. Well, our last section we learned the way to do that using the properties of logs. Log of u minus log of v is log of u over v. In this case, ln of x over x minus 1 equals ln of 2. And now you can unlog both sides and solve for x. So why don't you finish this? So when we unlog both sides, we get x over x minus 1 equal 2. Multiply both sides by x minus 1, giving you x equal 2 times x minus 1. Distribute x equals 2x minus 2, and then subtract an x from both sides. 0 equal x minus 2. X equals 2. Does that work? Well, if we plug 2 in, the original equation, we get ln of 2 minus ln of 1. Well, remember, any log of 1 is 0. That was one of our properties. So we get ln of 2 minus 0 equals ln of 2. So it does work. X equal 2 is our answer. It checks out. Okay, one last problem. This is number 2 of WebAssign. It's really kind of a throwback. It really belongs in the previous section. So we did a problem similar to this in the previous section, and what it involves is just writing both sides as a power of the same number. Now 64 is 4 to the third. It's also 8 times 8, which is 2 to the third times 2 to the third, or 2 to the sixth. 512 happens to be 2 to the ninth. Because 2 to the 10th is a kilobyte, which is 1024. 2 to the ninth is half of that. So 512 is 2 to the ninth. 1 over 2 to the ninth is 2 to the negative ninth. So there we have it. 2 to the 6x equals 2 to the negative 9. 6x has to equal negative 9. So x is negative 9/6, which simplifies to negative 3/2.